Debugging today's designs requires you to work in a mixed domain environment from DC to RF. The Tektronix MDO3000 oscilloscope offers all the essential tools you'll need to get your job done fast, saving you hours when verifying and debugging your designs. Here are a few everyday examples of engineering tasks you can do with this ultimate 6-in-1 integrated instrument. Let's take a look at each one and see how it's done simpler and faster than ever before. First, let's look at one of the most difficult challenges in the debug process: discovering and capturing signal anomalies. While probing signals on the circuit board, we see faint traces in the waveform, indicating infrequent events that do not look like the digital signals we expect. To investigate further, we turn on Fast ACK mode to speed up the acquisition of waveforms and quickly capture and display the anomalies. In this 3.3 volt digital signal, we can see occasional runt pulses, a little over 1 volt high. Next, we set up a runt trigger to capture each runt pulse. But how often are they occurring? With Wave Inspector, you can automatically search your signal for all instances of an event you specify. Wave Inspector will automatically mark every event so you can easily find them. Now we'll look at debugging a design with an SPI serial bus and a parallel bus with the MDO3000's integrated protocol analyzer and logic analyzer. To begin, we capture the 3 signals which make up an SPI serial bus. We define a few bus parameters and the scope automatically decodes the serial bus data, saving you hours of time and costly mistakes by avoiding manual decode of the bus data. We also want to examine an 8-bit parallel bus, so we will add the digital channels and turn on the parallel bus decode. We can now see the timing relationships between the serial and parallel bus data. You can program the serial trigger to capture specific events, such as every time the hex data value B0 is transmitted on the serial bus. The MDO3000 supports over 10 different serial protocols to match the needs of your design. Another common task is tracking down the source of noise in a design. Here we'll look at simple ways to do just that with the integrated spectrum analyzer in the MDO3000. While probing on the circuit board, we are seeing a very high-frequency signal riding on one of the low-frequency signals. In the time domain display, we see that the dominant noise is at about 900 MHz. Switching to the integrated spectrum analyzer, we set the center frequency to 900 MHz and the span to 2 MHz, and use a near-field probe to capture the radiated signals. Then we slowly move the loop antenna over the circuit board, looking for the highest signal level at 900 MHz. We find the strongest signal at the output of a clock generator circuit and determine the signal corresponds to the 9th harmonic of the 100 MHz Ethernet clock. In this case, a poor circuit board layout has resulted in magnetic coupling to other signals in the design. Let's look at another everyday task. Here we'll use the integrated signal generator in the MDO3000 series to create a stimulus for margin testing a design. To test the margin of a serial receiver, we simply capture a live signal with the scope's analog channel and load the signal into the integrated arbitrary function generator's edit memory. Now we have replicated our desired signal and can use this as the stimulus to our serial receiver. Next, we probe the signal at the output of the serial receiver. By decoding the output of the receiver, we can determine when errors begin to occur in the system. As we add noise to the serial signal coming from the MDO3000's AFG, we begin to see data packets disappearing, indicating bit errors. This testing indicates the noise margin in our receiver design. By simply replicating our desired signal and adding noise with our AFG, we were able to quickly check our design's performance. Even if you rarely deal with power measurements, the MDO3000 series power measurements enable you to quickly get the same accurate, repeatable results as a power supply expert. In this final example, we'll take a look at common power measurements and how they're done with the MDO3000. Here is the voltage and current at the input to an AC to DC converter. We then turn on the MDO3000's integrated 4-digit DVM to monitor the DC output voltage as we work. The graphical readout indicates the output voltage is very stable. The optional MDO3 power measurement application automatically makes a variety of measurements with the push of a button, easily and repeatably. Here are the input power quality measurements, including power, crest factor, and power factor, which characterize the effects of the power supply on the AC power source. The current harmonics measurements provide a frequency domain analysis of the input current in both graphical and tabular formats. And with that, we've been able to quickly make several very important and repeatable power measurements. In this video, we've shown you just a few of the many everyday tasks that can be done with the MDO3000 series, the ultimate 6-in-1 integrated oscilloscope.